So yesterday we discussed the framework runtime. So it consists of a core container. So whatever data which you want to manipulate or whichever data you want to play, everything will be stored in the core container. And the way we are going to display them and the way we are going to visualize them is done by the web container. And the data management itself, how to store, where to store, what type of data to store, in which table, everything will be taken care by your data access and integration layer. So all these are connected using the AOP, aspect oriented programming. That means separating a business logics. And at last you have something called as a test layer. So whatever piece of code you write, you need to test it before giving it to the next phase. So like let's say take a simple example, addition of two numbers. So if you know that 1 plus 1 equal to 2. So you need to write a simple test case that, okay, upon calling 1 plus 1 equal, like upon calling the addition method, and by sending these two numbers, I need to get a result of 3. So that means if you pass 1 and 2, if you get a result 3, that means your expected result and your actual result. If these both are equal, then your test case passed. So that's how you write a test case. So you should know what is the what would be the actual output, and you should calculate the actual output of your method. If your actual output of the method and whatever value you are assuming are both are correct, that means okay, you know the functionality, you are getting the output whatever you want. So even that, so that is called as unit testing. So that is also present. So that is done by this test layer. So you first write your like whatever objects you want, like whatever data you want to manipulate, you need to mention them within this core container, write all the business logic, then push it to web. Then the front end, the web will take care of all the visualizations, and the data will be stored in the data access. And next comes the test framework. So this is a complete architecture in a nutshell. So single framework will be able to support these many frameworks. Now, um, so whatever I explained, I just kept in the PPT. So it's the very first thing is Spring Core. This model is the core of Spring framework. It provides implementation features like IOC, dependency injection with a singleton design pattern. So whenever we are doing the coding, I'll explain you. We know yesterday I explained regarding the IOC, right? Inversion of control. We creating an object and using it. That is your normal way of execution. If you inverse the control, meaning Spring only creates the object for us in the runtime and you just use it. That is inversion of control. So this can be achieved by using simple annotations. And next is Spring Bean. Uh, Spring Bean uh, Spring Bean means if you take a simple login page, in a login page, your username and a password. These two are the only attributes which you require for a login page. So login name and password. These two are called the beans. Okay. Next is a Spring context. So this model is built on the base provided by the core and the beans, and is a medium to access any object defined and configured. So if you want to play around with this login name and password, if you take a sign up form, username, password, email, password, repeat password. If you take like all these are beans, right? If you want to play around with these variables, then you need something called as a Spring context. Next is your Spring expression language. It's called the Spell. So this module is an extension to expression language supported by the Java server pages. It is JSP. It is a powerful expression language for querying and manipulating an object graph at runtime. So you can just what you can call, you can just memorize the terminologies like what is spell, what is context, what is bean, and what is core. Whenever you're doing the coding, then you'll be able to recollect it. Next comes your data access layer. So it consists of 5 modules. So the JDBC. So
Oh,
JDBC.
nothing. Yeah, go ahead, go ahead.
Okay. So JDBC. So this module provides a JDBC abstraction layer, which eliminates the need of repetitive and unnecessary exception handling overhead. So yesterday when we're discussing about the exception handling, did you notice that we have something called as SQL exception within our exception hierarchy?
Yes, yes, yes.
Yes, right?
That comes
Yeah,
under the first category, right?
exactly. So whenever you're writing a simple SQL query, or if you want to perform SQL database operations, you need to explicitly handle them. Like there might be an SQL exception thrown, or if you have a primary key, and if you're trying to modify the primary key, then you'll get something called as no constant violation. So there are a lot and lots of exceptions there. So if you want to handle them, the Spring Data Access has this inbuilt JDBC. So this will be automatically handled. You only need to just write the code. So the main like if you see the legacy code and the latest Spring framework, you see the difference. There you write your own code, including the own code. You're writing you're writing code to handle exceptions, and there are lots of code involved. But when you come to Spring framework, you only write the logic. Whatever you want, you write the logic. Rest everything is handled. That's why Spring will be they're using Spring for faster app developments. Next comes your ORM. It stands for Object Relational Mapping. This model will provide the consistency portability to our code regardless of data access technologies based on the object-oriented mapping concept. Meaning, now take if you take a database, you must have seen when if you want to retrieve some records from a database, what do you write? Select something from so and so table where something equal to something. Are you familiar with this query? A simple select statement. Select star from table where table name equal to something. Familiar?
Yeah.
Yeah,
Yes, right. Yeah,
yeah.
yeah. So if you want to retrieve a data using a database, what do you work on? SQL statements. Select is the SQL statement, and upon what you're going to select a table. So if you want to work on databases using SQL, you work with statements and tables. Whereas when you're coming to Java, you work with classes and objects. Classes and objects. That's it. So the main difference between your SQL and your and a Java is in SQL you work with tables and columns. In Java you work with classes and objects. So class equivalent is your table. So again, same thing. You just memorize these words whenever we are doing the coding. You'll get to know. JMS,
So,
JMS. Sorry, you go ahead.
yeah, you mean in table we can contain some data. In
Mhm.
class, in programming, we contains a class. So the things which we contain in databases in terms of table is same like classes, right?
Yes, yes. So um,
Yeah.
now, take a simple database. If you want to insert a data to the database, what do you do? Insert into data in the table values. Within the values, you provide some data. That's how you insert some value to the database. Okay, so insert into something, something, something. Now, if you want to do the same thing from a Java application, you need to have a class, right? To like take a simple login page. Okay, take a simple sign up page. Username, password, email. So these are the only three fields which I need to store them in my database. So as a like let's say you are a backend developer, and if you want to store these values within your database, you simply execute a insert query. Insert into sign up table values, username, password, and email. This is how you write a simple query. But if in the real world, users will directly put input your username, password, and email in a front end page. It can be form or it can be HTML or some front end technology. You as a Java developer, you need to take those values. So how do you read the values? In Java, you only work with class and objects, right? So whatever values you read from the front end, those values should be taken by the class, and the class in turn will trigger one method. That method will store those values, and this method will in turn trigger a query to the database to store these values. So you have two ways. Like as a developer, you have two ways to insert a data. You can directly issue a SQL statement, or you can do it from your from the Java language. But since your application is available to users they have you have only one way. The users have only one way. They'll only provide the data, and you need to take the data and issue a insert to your database. So for if you work with the insert query, you work with insert, that's the SQL statement, and the table name. So query statement and the table name. The second way is your Java. When you work with Java, you work with classes and objects. That's called as object relational mapping, ORM.
Okay, got it.
Yeah. Next comes your JMS. So it stands for Java Messaging Service. This model contains the features of producing and consuming messages among various clients. Meaning, let's say, you know your NEFT transactions, right? NEFT transactions. They come under, how can you call? Okay, take a bulk subscriber. You take an Amazon as an example. Amazon sends you messages like if there is any offers on Black Friday. Take this example. So it needs to send messages to all the customers with a specific criteria. Like let's say if he's a prime customer, prime user, he need to get one message. If he's a non-prime user, he need to get some other message. If we take these two scenarios, who is the producer? Now Amazon service is the producer, which will be producing some messages. And who is the consumer? You as a user. It can be prime customer or it can be non-prime customer. You're receiving the messages. So if you want to send these bulk messages, you use a JMS. So that is just a simple example, not a real world example, because in real world we have different like you have Kafka, you have RabbitMQ. So there are many streaming platforms available, but Java is capable of doing all this using the JMS. So there are applications which will be using JMS, but in the real world there are other competitors also for JMS. Next is a transaction. Transaction meaning like whatever operation you do on a database, insert, select, update, delete, whatever you do, all these are called as transactions. So, so these four, uh, all these modules are covered. Spring Data Access will be able to take care. So that whole module will consist of all these JDBC, ORM, JMS, and transaction. Is this clear? Like how are you going to play with data? Yep.
Yeah.
Next is a Spring Web framework. So the web framework will give you web servlet, web sockets, and web portlets. So it has all all these modules. So if you want to visual like same thing, whatever we explained in the previous PPT, if you want to visualize whatever data you want, you simply put them in the JSP or HTML or JSF, any front-end framework. So you as a backend developer, you will send data from your backend to front-end. It's a job of the front-end team to take the data, do some colorings there, like if it is a title you put as bold, if it is a table you put as a table. So do all those visualization, and then you display it to the end user. So those kind of tools are also supported by your Spring Web framework, Spring Web. So what are the advantages of Spring? If you see, it has a predefined template. You need not throw and catch exceptions unnecessarily, or you need not inject your direct dependencies. So everything is annotation based, right? So it has predefined templates. Simply use it. You only write what you want. That's it. You only write the business logic. Rest everything is defined, like it's defined as a predefined template. You simply use annotation, it will do the job for you. And loose coupling. So the main advantage of IOC, inversion of control, is loose coupling. In my Java class, I have one class, and if I'm going to infer some other class, what will I do? Like class A object equal to new class A. So now my new class is always tightly bound to class A because I'm inferring an object there. Whereas inversion of control, I'm simply inversing the control, meaning Spring is only providing the object of class A. So class A and the are my new class, both are loosely coupled. So always aim for loose coupling. That means no two classes should be much dependent on each other. They must be they must be loosely like suppose take a simple Facebook example, okay? And let's say a comment button and a like button. Let's say you're working on these two functionalities. So if comment button and like button are both interrelated, tomorrow whatever change I make on the comment button functionality, it will adversely impact the like button functionality also if they're tightly coupled. If they're loosely coupled, that means if common button functionality is different, and if like button functionality is different and like they're not related to each other, if I change the common functionality source code, my like button functionality will like it will not change because they're loosely coupled. You're getting the idea? What does coupling mean?
Yeah.
Yeah. Then easy to test, lightweight, and fast development. Because of predefined templates, uh, the development will be very fast. Lightweight, lightweight meaning like the memory consumption, the ease of execution, the speed of execution, everything differs. So with this, your application is going to be lightweight. That means there won't be much impact on your databases also by using Spring Framework, because everything will be handled and whatever dependency you want only that is being injected in the runtime. So if you want to simply start a Spring Boot project from scratch, you need to just navigate to this URL. I'll do that now. And with the Spring, we need there are simple concepts we need to know. That is Maven, what is Postman, what is MySQL. Okay, let me tell you those. So when you're working in your real world, most of applications will be in Maven build or Gradle build, Gradle, Gradle, or Ant build, ANT, Ant. So Ant is a legacy technology. So as far as I have seen, 90% of applications will be working on Maven only, Maven, Maven. So what exactly is Maven? Maven is a powerful project management tool that is based on POM, Project Object Model. It is used to it is used for project build, dependency, and documentation. So you have written some piece of source code, and you need to execute this source code on a server, because obviously at the end of the day, whatever application source code you write, you need to build it in the form of a jar file, and jar or var or anything, and that jar file needs to be deployed on a server. That server will be serving your application to the web browser. That's a simple case. So to get the jar file, to build everything, you need to have something called as a POM. So Maven is the build tool and POM is a descriptor for it, project object model. So what does it do is it generates the source code, it generates the documentation from the source code, it compiles the source code, packages the compile code into jar or a zip file, installs the package code in a local repository, and I'll not dive into direct coding. I'll simply just tell you what will happen, what this will do. Okay, run as Maven build, clean install. See, this is called as pom.xml. Pom.xml means that is the descriptor for my project, entire project. So build success. If you see at 545, now itself, I have something called as executable jar file. You can just click on here, cmd, it open a command prompt here, and using java-jar command, java-jar springboot.jar. See see this? My Spring Boot application, like data, the repositories are initialized, and my Tomcat port is active, and it started my whole application within 2.9 seconds. So what does this mean? I just gave a simple java-jar command, meaning I'm just asking my Java to execute this jar. What does this jar have? Just, Class.com Java. So whatever source code I have here, controller.class. So this is a controller dot, this is dot Java class which I can read, and this is dot class which machine can read. Main model book.class, books.java, books.class. This is books.repository. If you go to repository, it's books.class. So if I run a simple maven install command, what it does is it compiles the whole source code and it will give it to me in a form of jar file. That's the meaning. What is it? This is a simple jar. I can simply rename them. We'll see, put it, let's say desktop is my server, okay? I can simply do a build, put it on my server, and on the server issue java-jar command. That's it. It'll trigger. So this is how you use a we use the Maven tool. It'll generate the source code. It'll generate the documentation of the source code. It'll compile the source code and it'll package the compile code into a jar. Jar means Java archive. And you'll come across words called var also. Var is web archive. And there's one more thing called as EAR. EAR, that is enterprise archive. So your application will be built of like they can be built in 3 types using the Maven: jar, var, and EAR. Is it clear? What is Maven and how to install it? Why are we using Maven?
Understand.
Everyone? Asha, I see Srinivas Rose joining today.
Yeah.
Okay. Next comes your Postman. So this is a tool. This is a API testing tool. So most of your industry related projects, you'll be working on Postman or SOAP UI. So why do we need them is to test your APIs. Just a minute,
Which is in XML format, JSON format, right? So we are
uh,
copying this in in Postman, and we are just run that so that
yes.
it will execute in like MuleSoft with middleware. So exact API transformation is there. That is how we test the APIs, right? Am I right?
Yes. So you have written some piece of code, and you don't know if you want to test that piece of code, simply put that URL, provide whatever data you want to give, and hit it. You should get a response. So to get all those things, you need these API testing tools. So you can use Postman or SOAP UI. So I basically 99% of times I'll be using Postman only. There are some cases where you'll be forced to use SOAP UI. Then so both will work the same. Simply provide a API URL, provide the body, and just hit it. You'll get a response.
In some cases, we will use a ready API, right? What is the purpose of ready API then?
Ready API or Rapid API. Rapid API is that is a build, that is an extension in Visual Studio Code. So all the extensions, like you have different versions. You take anything, like if you take a simple laptop, you have Mac, you have Windows, you have Linux, and under Windows you have Dell, HP. You have many companies, right? All the different versions. But what is the actual work of a laptop to accomplish your task?
Okay.
So what is the actual work of my Postman or SOAP UI to test my API? That is my only my background layer. Like I want to test my API. If for that, use anything, use Postman SOAP UI or Rapid API or Ready API, anything. All the frameworks. It is up to your
Okay.
client or up to your project, like what they want to use.
Okay.
Okay,
Yeah.
but the main idea behind it is to test the API.
Totally, it is totally related to backend only, no? Hit the call so that if the server responds with 200 okay, then it's okay. If not, again, we need to check all the, I mean, whatever the errors, again, backtrack and that all, right?
Yes, yes, yes. Yes.
So it means that if we get 200 OK means the server is responding. If not,
See, not
call is not going to backend.
yeah. So 200 OK response, like there is a concept called as HTTP status codes.
Yes.
So if 200 OK will be given, like if you want to put something or if you want to get something, then you'll get 200 OK status codes. Suppose if you're getting a 401, 401, that is not
Yeah.
authorized. 403,
Unauthorized.
that is forbidden.
Forbidden. Yeah.
404, not found.
Hmm.
So then 201, there's something called 201. 201 means when you're trying to put something, meaning if you're trying to update a value, that's called a put. If that is okay, you'll get a 201. So 200 is not the only code which you should be expecting. So suppose if you want to test a negative scenario, meaning if you don't want to test a login, like you have a login functionality, you provide some invalid username and password. What should you get? You should get a 403. But that doesn't mean that that is failing the test case, right? Because you're expecting a 403. Getting my point?
Yeah.
Yeah. So um, 200 OK status doesn't mean that our API is working, or 403 forbidden or 403 forbidden or 404 not found doesn't mean that our API is not working. It can be any of them because our method can throw anything
Okay.
based on our functionality and based on your testing inputs. If you provide a valid username and a password, the best case is 200. If you provide a invalid username and invalid password, you'll get a 403. Both are correct test cases, valid test cases. But if you provide invalid username and a password and if you get a 200, that is an invalid test case. Clear?
Yeah.
Yeah. And there's something called as H2 database. So when you're working with our standalone Spring Boot applications, like for these tutorials, like we are going to use the in-memory database. So by default, Spring has a embedded in-memory database that is called the H2 database. It is a relational database management system written in Java. So it is generally used for unit testing. So it stores the data in memory and it does not process the data on the disk. So it does not process the data on disk mean like until and unless your server is up and running, whatever data you are going to manipulate or add or delete, everything will be present by until your server is up and running. Once you terminate the server, everything will be lost. So this is just for our testing purposes only. We are going to use the H2 database. So you don't have any configuration. It's very easy to use. It is lightweight and fast. It supports SQL and JDBC API, and it also provides a web console to maintain the database. In your real world applications, what do you use? You can use Oracle databases, MySQL database, PostgreSQL database. If you're using if you're into Amazon, if you're into cloud, you can use MariaDB. MariaDB. If you're working with NoSQL, you can use MongoDB. So there are different types of databases which you'll be working on. H2 data, like if you need at least one database, how the database is working, then it is similar to all the other databases. The configuration is similar.
Okay.
Okay. So let's say if you're asked to uh, s- um, simply start a code a simple Spring Boot application. So the very first thing you can do is go to Spring Initializer. Here it'll ask you what all we need. So you're going to write in Java and you want a prototype of Maven. I want to use a Spring Boot version of 3.0.1. You can use any version based on your article, like based on your requirement. Use any version and group. This will create a package structure for you. So previously, how we are going to work on packages com.java.basics, com.java.oops, com.java.collections. That's our package structure, right? Similarly, what group you want to work on? So com.tetra spring. Let me put a spring. So at the end, spring project, spring project for tetra course. Okay, let's put something here. So this is the description. And if you see what are we giving here, it is the project metadata, meaning whenever you get a jar file out of it, like what is my packaging, it is set to jar. So if I build this project, I'm going to get a jar file. So if you're going to open the jar file, and if someone sees the metadata of it, they'll be able to see this. Okay, this project is built as a Spring project for the Tetra course. And here you can add dependencies. So what are dependencies? Let me tell you a simple example. Mhm. Mm. Now let's say um, protected main is the class, and I'm extending the protected ex. So this ex is coming from access.protected ex package. That is this one. So this class would be a dependency for me for this main method. That's why I'm importing the class. If I don't import this, I'll get an error because protected ex is a dependency in the protected main class. Similarly, if you when you're working with your Spring application, there are lots and lots of dependencies. Why? Because your Spring framework is a home to all these frameworks. Data access, web, AOP, beans, test, everything. So it is a home for all these frameworks. So each and every framework will have its own dependency. So if you want each and every dependency from each and every framework, you need to tell the Spring that, okay, I need this dependency. I need this jar file from this web module. I need a jar file. I need a JDBC jar from data access module. I need a transaction jar from this database module. So you need to tell the Spring that, okay, you need these many dependencies. So for that, initially, simply just add one Spring Web dependency, um, time Spring security. Hmm. I'm just adding some random dependencies, okay? How are you going to get them? That's it. NoSQL, MongoDB. Okay, let's say I want to add a MongoDB. Okay, and I just click on generate. So I'll get something called as spring.zip here. Spring.zip. The name is same as the artifact name. Show in folder. Right click. You need to extract it to a separate folder. Do not open the archive or do not extract the files there itself. Extract it to the folder name as same as your zip file. So refresh this, and this is a compressed zip file. This is a file folder. So if you open this, see the complete structure. You have something called as POM. So wherever you see a POM, that means, okay, POM means project object model. So this is a descriptor for this is a descriptor of type Maven. So clearly you can tell this as a Maven project. So for the very first time, let's say you're given this task to import it, okay? So this is the same way how they're going to push the code to our repository also. So whenever you clone a code from your repository, you'll get this type of folder. And you need to know how to import them to your Eclipse. Because now I started like we started the code from scratch. That's why uh, I'm going to simply create a project and I'm going to create everything from scratch. But when you are working, you won't create anything from scratch. You should, for that you need to first import the existing model to your Eclipse. So you need to know how and what to import. So click on import projects, and here you have general, Gradle, Maven, everything. So general means whatever we discussed till date. So they do not provide if you take collection framework, exception handling, anything you take, whatever we discussed till yesterday, all of the general projects. They don't require any Maven or they don't require any Gradle. So simply click on general, existing project to workspace, click on next, and wherever you're storing a source code, you need to import them. But since we are working with Maven now, click on Maven, click on existing Maven projects. This one, hit browse, click on desktop, select the Spring folder, click on select folder. It will automatically detect the POM XML. Because you're importing a Maven project, it will automatically detect the POM XML. Click on finish. Now you can see here importing Maven projects 9%. You need to wait until it goes to 100%. Just stop me if you're not able to understand anything here.
This is Spring UI part,
No, this is Eclipse only. I think
but
it's
you imported a POM file, right? So it shows the description of Maven.
yeah, that is what I was telling, right?
Yeah,
So
but here
s-
is nothing is showing, right? So I
Maven is
got doubt.
Maven is a project management tool that is based on POM. So if you have a POM XML, that means it is a Maven project.
Mhm. Uh,
So now my import is complete. If you open this, you see this common.spring. This is my the what is the name of it? Group name. This is the group name, and it created a simple class for me, which has the main method. And you see something called as at that Spring Boot application. This is the annotation which will tell that okay, I am working with Spring Boot. So at that Spring Boot annotation is an annotation which is written, which is written on a class which has the main method. So wherever you see this annotation, that means straight away take it as okay, I'm working with a Spring Boot application. Once you run the Spring Boot application, what it will do is it will initialize all the classes, it will initialize your databases, it will do all the dependency injections, and it will start a Tomcat server. Tomcat server. Just a minute, let me show you that. See, once I start my Spring application, it will initialize all the interfaces and classes. And Tomcat is a server. From now on, you'll be working with servers also. Why do we require a server? To serve the application. In the real world, your application will be dependent on server, right? That server can be of any type. So Spring has a embedded Tomcat server. So whenever you run the Spring, this Tomcat will be initialized automatically. Okay, and Hikari pool. Hikari pool means this is your database connections. So um, at the rate Spring Boot application and a Maven and a main method. If you simply run this one, the backend functionality is this one. Starting your initializing all your classes, starting your Tomcat server, initializing your database and everything. It does all these functions. It does all these steps once you simply trigger this. Anyways, now it will not work. That's it. Let me just change the color of it.
It says port 8080 was already in use. The
Yes, yes.
Tomcat.
Yeah, I'll tell you how to resolve them. So the issue is it's saying that okay, you're trying to start a Tomcat. Like by default, our Spring Boot application will be up on 8080 port only. And it's telling that okay, Tomcat like 8080 is already in use. How to identify what is using that port? Use a CMD. I'll give you just a minute. Here's the chat box. Make use of NET ST80 netstart -a -n -o find str 8080. So this is the command netstart -a -n -o. Use a pipe symbol. Find str port 8080. If you hit this, uh, this is the process 70128 We know that if your Java application is up and running, that means it is a process. Again, same interlink with that concept. By default, every Java application will have a single one thread running. What is thread? It's a Java process. If you are having something like if you have a Java process, that means what you have an ID associated with it. Correct. So if you take your mobile phone is identified uniquely by your IMEI number or the physical address. Similarly, if you're having a Java process, it is uniquely identified by its process ID. That is 70128. Simply kill it using the task kill command. PID 70128. That's it. Success. The process with PID has been terminated. So again, if you issue a netstart command, there's no process running on 8080. I will give you this command also. So just in case if you lose commands also, like just simply Google, if you just Google it, you'll get these commands, like how to find a process. Now if I run this, no active profile set, Spring modules found. So it'll scan all the Spring modules. It'll finish up the data repository also, meaning your database. It'll start the Tomcat service, and it is up and running with port 8080. So how to access this server now? Mm, see, Google.com is a host. So go to a command prompt. Simply issue ping command, PING google.com. So if you see, this is a host with this IP address, IPv6 address. Similarly, I have a host for me. What is that? That is localhost. Localhost, and my Tomcat is up and running with 8080. Please, just a minute. Actually, I already have Angular application up and running. That's why I'm getting this. So now, if I stop the server here, and if I try to log in here, you'll see this. The site can't be reached. Localhost refused to connect. That means whenever I start this application, my Spring is automatically starting the server. What is the server? Tomcat server. Now again, if I refresh this page, it will come up. You're getting the difference? Yes, no.
Yeah.
Got it.
Got it? Yeah. Um, like, like let's say, like if it is too much for today, like we can stop it. Uh,
Yeah.
yeah,
Then
got it, got
yeah.
it.
What the
No,
purpose of
we will
Node.js?
get into project, then only we will get to understand each and everything and connectivity, how to proceed and how to stop and where to navigate, where to check if we come across anything.
Yeah,
Bapre.
yeah, yeah. That's why I'm not discussing in detail with like what annotation is, what variable is, and I'm not going to discuss all of them. So I have already written piece of code for you. So this is a simple piece of code, and I'm going to explain you what that will do. With this code, like you'll get to know the simple CRUD operations. Then it will be very easy. Like I have already like whatever notes I want to tell you, I have written it here itself. So whenever you have any doubt, right, simply go to the repository. Like put like if you want, you can put it. You can close the source code or just simply go to the repository and check it. So how I'm trying to give it is like everything should be given in a nutshell for you, so that whenever you want, simply go there, get your required info. That's how I wanted to tell this. Otherwise, complete Spring Framework it will take more than 1.5 months for explaining each and every annotation and what annotation will do, what the dependency injection will do. If you want to go in that way, it will take lots and lots of time. Just let me stop the recording.